Okay, here are the inequalities that we're going to solve with this particular lesson. We have 8x is less than or equal to 48. Let's solve that one. So this is what we call multiplication, right? Because 8 times x, that would be 8x, less than or equal to 48. So when we go to solve this, we have one step. And that one step is to isolate our x. So let's do that. We have 8x less than or equal to 48. When you solve an inequality, what you're really doing is treating this inequality symbol as an equation, as an equal sign, just long enough for you to do the solving. So we're going to do the opposite here and do division. Divide by 8, whatever's attached to your x. 8 divided by 8 is 1, so that leaves me x less than or equal to 48 divided by 8 is 6. Now, are all of these going to come out to be nice, pretty, plain numbers? No, they're not. It's just I'm showing you how to do an example of each style. So don't get bogged down on how big or small the numbers are, if they're positive or negative, fractions, decimals. It's the procedures that you're going through that are going to make the difference. All right. So you have x is less than or equal to 6. Now, if I asked you to write that in set builder notation, here's what you would do. You would say the set of all x, that's what that x stands for, such that, there's your vertical line, x is less than or equal to 6. So that's how you would write your answer in set builder notation. See, it's the same thing, you're just adding a couple of little frills around the sides, okay? All right, now let's graph it. So because it's less than or equal to, this is going to be a closed circle. So let's go to positive 6, put a closed circle. And again, remember what I said. I'm adjusting my number lines according to the answers that we're going to get, just so that I can show you because the screen's only so big. So less than or equal to means a closed circle, and less than points to the left. So we're going to take this and we're going to shade left. So we're going to shade left. Left is less than, and make sure you put your arrows, okay? Awesome. Now let's do the next one. We have x minus 5 is greater than negative 4. This is a subtraction, so we have to do the opposite, and the opposite would be addition, okay? So we have x minus 5 is greater than negative 4. We're going to do the opposite, which is add, and we're going to get our solution. And our solution is going to be x is greater than a negative 4 and a positive 5 make a positive 1. And if I was going to write this in set builder notation, it would be the set of all x such that x is greater than 1. Okay? So there's that. Now, when I go to graph this, notice how this is a greater than sign. It's not greater than or equal to, so it's going to be an open circle. So we're going to go to positive 1. We're going to put an open circle. So I'm going to erase this just so that you can see what the open circle looks like. And then we're going to shade greater than. Okay, greater than goes where? Greater than goes to the right. There it is. So we're going to shade. Make sure you put your arrows to show it's infinite and continues. All right, now let's look at our next problem. Our next problem says x plus 6. So the opposite of addition is subtraction. So let's do that. We have x plus 6 is greater than or equal to 10. So we're going to do the opposite of addition, which is subtraction. We're going to take 6 away from both sides, and that's going to leave me x there. Oh, let me write that up to the side so I have room to do the last one. X greater than or equal to 10, take away 6, which is 4. So if I was going to write that in set builder notation, it would be squiggly. They call them braces. I call them squiggles. X for the set of all x such that x is greater than or equal to positive 4. And this is going to be, because it's got the equal to sign under it, it's just like the very first one that we did, so it's closed. So we're going to go to positive 4. We're going to close our circle, meaning we're going to fill it all the way in. And then I want to shade greater than or equal to. So greater than or equal to shades to the right. So here we go. We don't have as far to shade on this one because I cheated on the number line. All right. Now let's look at our last one. This says x divided by 2. Remember that the fraction bar means division. So I have x divided by 2 is less than 4. So to solve this one, what's the opposite of division? Multiplication, that's right. So I'm going to do this. I'm going to multiply both sides by 2 over here so that I have enough room. So 2 and 2 divide each other out. That's the whole purpose in doing that. So I get x is less than 4 times 2 is 8. So if I was going to write this in set builder notation, I would write my little braces, or my squiggles as I call them, set of all x such that x is less than 8. And then you always close your set, close your little squiggles. All right, so now this one, there's no line under here, which means it's not equal to, so it's like the second one we did. It's open. So let's go to 8. Again, I'm going to erase just so that you can see that that's an open circle. You obviously don't have to do that. And then we're going to shade less than. Less than shades left. So that would be all of that down here. And we put our arrow signs, okay? All right. I've graphed one of each style, so when you go to practice, at least you'll have an example for you to look at. All right? Come back next time and we're going to do some that are a little more challenging.